a will get cancelled, then you will get only x cos theta upon a. If your line is intersecting the ellipse, I am just going to cover the area of this one. Hello everyone, welcome back to Ellen Overseas. Let's continue our special series. In this series, we will cover 45 important topics in 45 days, which will really helpful to all JEE Mains aspirant. And the topic distributions are 15 physics, 15 chemistry and 15 maths. I am going to cover this math section here. This is the study challenge we will cover in this series. So without wasting too much time, let's start our topic. And our topic is tangent, which is under the chapter ellipse. We are going to discuss especially the tangent part from the chapter ellipse. And you can see a lot of previous year question on the basis of this topic in your JEE Mains. So the first one is the point form or a Cartesian form. So this is what, first of all, you need to understand this thing. Let's say you have one ellipse that is something like as this type. Now here you have one point of contact which is P. Let's say x1, y1. Now I want to design a tangent at this point of contact. And I want to write the equation of this tangent. So how I can write? This one we can easily write with the help of basic transformation. If you know the transformation, so this part will make you very easy, very comfortable. Basic transformation, if you don't have an idea, so I am going to elaborate it again. You can just replace your x square with the help of x into x1 and y square with the help of y into y1. Because you know, we are doing here ellipse. So we have only x square and y square. Apart from this, you can also replace your x, if there is, then x plus x1 upon 2 as well as y with y plus y1 upon 2. So here, what I am going to do, let's say I have one ellipse and the equation of this ellipse, that is something like x square upon a square plus y square upon b square is equal to 1. Now at this point of contact, I want to write the equation of tangent. So you can do the transformation, which is something like x into x1 you can replace. Similarly, there is a square, no change, and y square you can replace with y into y1. Then you will get equation of tangent in point form or a Cartesian form. If you have point of contact, then you can apply this one. It is quite easy. Now the second one is parametric form. For the parametric, we should have an idea about the parameter, and the parameter is a cos theta and b sin theta, behalf of ellipse, right? This is a cos theta and b sin theta. Again, I would like to do same thing. I have one ellipse, I have one point of contact, but now this time I have a point of contact with respect to parametric form. That is something like you have one ellipse and this point of contact, now I have a cos theta and b sin theta. Now I want to write the equation of tangent again, right? So this equation of tangent you will get what? Which is simple. Again we are going to do same work. X into x1 upon a square plus y into y1 upon b square we already have covered in previous one, point form. That is x1 upon a square y into y1 upon b square is equal to 1. Here I am going to replace my data x1 with a cos theta, y1 with b sin theta. So after this, a will get cancelled, then you will get only x cos theta upon a. Similarly, b will get cancelled, you will get y sin theta upon b is equal to 1 is your equation of tangent in parametric form. Quite easy to derive as well as to remember. Now here you can also observe one more thing. That is what? Here you will get, it is something like ax plus by plus c. You can treat it like ax plus by plus c is equal to 0. General equation of a line. Then you can easily write the slope, that is minus a upon b, and the slope you will get minus b upon a cot theta from this form, right? Fine. Now the next one is slope form, and the slope form kind of very important one. As I told you, we have a parabola as well as circle. If you have external point, same, if you have external point, I don't have now this time point of contact. First of all, you need to understand the need of slope form. For example, you have one ellipse, but now this time I am not giving you point of contact. So in that case, let's say you have one external point, that is something like P. From this point, I am telling you design the equation of tangent. So this is our main target, right? Now here also you can observe the basic things, like this one would be the second. If your line is intersecting your ellipse, it will make itself as a second, as well as if it touch only, so it will make itself as a tangent, right? There is one more case, if this line or a one line which is not intersecting, not touching, so it may be outside the ellipse anywhere. So there will be the particular condition we will see. Interesting one. Now here you will get the basic calculation. You will get b square x square plus a square mx plus c whole square is equal to a square b square. Further, I am interested to solve this more, and I am interested to write this equation in terms of quadratic in x, that is ax square plus bx plus c, which is something like as this type. Now something we can conclude behalf of this equation. Listen me well. Here, if a line, listen me again, if a line is only touching this ellipse, so at this point the root must be equal to 0. The root must be equal. Then in that case your discriminant must be equal to 0 behalf of your quadratic equation. And yes, I am going to follow this thing. If it is tangent, so discriminant must be equal to 0. Next, if your line is intersecting the ellipse, if your line is intersecting the ellipse, then in that case you will get real roots. If it is real, so your discriminant must be greater than 0. Yes or no? Definitely. So that's why it will make discriminant greater than 0 for second. Now the next one. Similarly, if it is not intersecting, not touching, so that means in that case your discriminant must be less than 0. Your line will passes from any outside the ellipse, right? Passes through any points. Now further, now again come to the point, when discriminant equal to 0, I will get c square is equal to a square m square plus b square from this equation. And this one known as condition of tangency, always remember this thing. Condition of tangency with respect to ellipse. If I want to write the equation of tangent in slope form, then simply I can replace c in y is equal to mx plus c. Then I will get y is equal to mx, and here I am going to replace c with the condition of tangency I have, plus minus square root of a square m square plus b square, and which is always a tangent to the ellipse for any value of m belongs to R. This one is important one, and the how to use this one is also, listen me well. If you have point of contact, you can use your first one point form or a Cartesian or a parametric, no restriction. But if you don't have point of contact, any external point you have, then in that case you should use slope form, right? Fine. So this is behalf of conceptual thing. Now it's time to apply our knowledge in a one previous year question, and I have a one previous year question, which is the area in square unit we need to find of the quadrilateral formed by the tangents at the end points of the lateral recta, it means lattice rectums to the ellipse, and this question from 2015. Now as we all know, first of all you just need to depict your given data in your diagram. This is the perfect way to solve any particular question from especially the coordinate geometry, right? So I am going to depict the given data here, that is something like in this way. I have an ellipse and here I am going to make one tangents at end of latus rectum, right? So you have latus rectum here as well as here. I am going to work here only. Why? Because we have the symmetric curve. Because of symmetricity, they are asking to find the area of the quadrilateral, that is something like A, B, C, D, A. We are going to find. But my concept is what? See, I am just going to cover the area of this one, AOB triangle. I will find the area of triangle AOB, and then once when we have, I will multiply with the 4 because of the symmetricity of the curve. Same area we have here as well as here as well as here, right? So now for symmetricity, first of all, we should have an idea about the coordinate of P, and yes, we have the coordinate of P, that is what? A comma B square upon A, end of latus rectum, right? Now for this we should have an idea about A as well as B as well as E. No doubt we have A and B because we have ellipse equation, that is x square upon 9 plus y square upon 5 is equal to 1, right? So here we need to find the eccentricity, and we can find it very easily. The eccentricity you will get what? Square root of 1 minus 5 upon 9, then you will get 9 minus 5, 4 upon 9, that means 2 upon 3. Now here once when we have eccentricity, so we can write the actual coordinate of P. Yes, so P would be what? A, that means E we have 2 upon 3 and A we have 3, so you can write here is 2, and the coordinate of Y you will get B square upon A, so the B square you have 5 and the upon A you have 3, so P we have 2 5 by 3. We have the point of contact. Now we are going to design the equation of tangent. With the help of point form or a Cartesian form we can write, because we have a point of contact. And yes, so the point form, that means equation of tangent, I will get what? X into x1, that means here I am going to apply x into x1 upon A, that means 9, y into y1 upon 5, which is equal to 1. Now we have the P, that is 2 5 by 3 as a point of contact. So 2 5 by 3 I am going to write here, that is 2x upon 9, 5 y upon 3 into 5, you will get 1. So 5 will get cancelled. We have the equation, that is simple, 2x plus 3y is equal to 9 or minus 9 is equal to 0, you can say. This is, you have the equation of tangent. Now what I am going to do here, I have equation of tangent. I am going to find the coordinate of B as well as the coordinate of A, and we can find it very easily because B is the coordinate on x-axis. Similarly, A is the coordinate on y-axis, right? This is your x-axis and y-axis. So for B, we should have y is equal to 0, right? So for B, y we should put here 0. So x you will get as a 9 upon 2, as well as for A your x will become 0. So x coordinate I am going to put as a 0, y you will get 3. Now we have this length base as a 9 by 2 and this one is 3. Why? Because A is 0, 3 and B we have 9 by 2, 0, right? Now we have the base, we have the height, so we can find very easily the area of the triangle. So area of triangle AOB or OAB, whatever, you will get half base into height, that is 9 by 2 into 3. So in short you will get 27 by 4, you know. Don't be quick. This is not the final answer, right? The final answer is what? We have the area of this portion is 27 upon 4, but Same we have here and here and here. So we should multiply with 4 in 27 by 4. So the final area, you will get what? Area of quadrilateral, you will get 4 times of 27 by 4. That is 27 only, right? So you will get option B would be the right one. That's all from my side on this topic. Don't forget to watch the complete series. The playlist link is available in description box. Still, if you have any query or any suggestion, feel free to reach out to us through the comment section. For more, stay tuned with us. Thank you.